Okay, we're at the last part of the review for the similarity and right triangle trigonometry test. So let's go through it. 21 didn't have numbers on it, so I added some numbers here, the 18 and the 37. Please make sure to add those numbers on your paper. All right, so we're looking for the measure of angle C, which is the theta symbol here. Once again, we're going to go back to SOHCAHTOA. And in order to figure out which trig ratio we're going to use, we'll have to label, of course. 18 is the opposite side, and 37 is the hypotenuse. So we can see that we have to use the ratio for sine. So let's write the sine of angle C equals opposite over hypotenuse. The sine of angle C equals the opposite side is 18. The hypotenuse is 37. And remember, we do not cross multiply here. We don't put a 1 underneath the sine of C. Whenever you're looking for an angle, we're going to use an inverse trig ratio. So we're going to write that C equals the inverse sine of 18 over 37. And let's type that into the calculator. Second sine 18 divided by 37. And we're going to come up with 29.1 degrees. All right, next up, 22 and 23. I just wrote these out. 22, what are the postulates used to prove that two triangles are congruent? And there are 5 of those. Side, 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 angle, side, angle, side, angle, 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 side, and hypotenuse leg. So SSS, SAS, ASA, AAS, and HL. Hopefully you remember what's the one postulate that does not exist. Well, there's 2 of them that don't exist that we never use. Angle, 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 and side, side, angle. We never use those. 23 asks what are the postulates used to prove that 2 triangles are similar. Now there are only 3 of these. Side, 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 and angle, angle. All right, so next up, 24. 24 says the sine of 38 degrees equals the cosine of something else. 25 says the cosine of 50 degrees equals the sine of something else. Now, we're going to use properties of what we call cofunctions. And I've just drawn a diagram here. It's not really important what this looks like, but we're going to use this in order to figure this out. So let's say we put the 38 degrees here. We put 38 degrees over there. If we put 38 degrees over there, this angle over here has to be 52 degrees, because we know both of these acute angles have to add up to 90 degrees, and once again, if this is 38, this is 90 minus 38, which is 52. The sine of this angle has to be the same as the cosine of this angle. So the sine of 38 degrees has to be equal to the cosine of 52 degrees. Now, I can expand this a little bit further, and let's look at the cosine of 38 degrees. So the cosine of this angle has to be the same as the sine of this angle. So the cosine of 38 has to be the same as the sine of 52. And one last one, let's look at the tangent. So the tangent of this angle has to be the same as the reciprocal of the tangent of this one. So the tangent of 38 has to be equal to, now in order to write reciprocal, I write 1 over the tangent of 52 degrees. So once again, sine of this angle, same as the cosine of this angle. Cosine of this angle, same as the sine of that angle. And tangent of this angle, same as the reciprocal of the tangent of this one. All right, let's erase for the next one. We have the cosine of 50 degrees equals the sine of some angle. So let's say this angle is 50 degrees. If this angle is 50 degrees, this angle over here has to be 40 degrees. And we just said that the cosine of this angle has to be the same as the sine of this angle, and we would write cosine of 50 degrees equals the sine of 40 degrees. You can also verify this in your calculator, which wouldn't be a bad idea on the test. Let's type in cosine of 50 degrees, and we get this big long number, 0.6427, and so on. Now, let's type in the sine of 40 degrees. As you can see, we get exactly the same thing. All right, next up, last problem. It says find the area of the figure using the given information. Area of a parallelogram, which is the same formula for area of a rectangle. We know that's equal to base times height. And that's what we have over here. We have a rectangle. The area of a triangle, the formula for that is 1/2 base times height. So that's what we have here. Now, in order to find the area of the figure, we need to find the area of the rectangle, the area of the triangle, and then add both of them up. Now, we're given some information. The measure of angle B is 40 degrees. That goes here. The measure of side DC is 16 inches, and I've added that here. The measure of side BC is 12 inches, and I've added that here. Now, we're missing certain parts from both these figures so that we can't just use the formulas outright. Now, it says the area equals base times height. We actually have the base of the parallelogram. The base is equal to 16 inches because opposite sides of a parallelogram are congruent. What we are missing is the height, and I'm going to write that over here. I'm going to write an h over here. If I write an h over here, I also have to write an h over there. Now, for the triangle, it says 1/2 base times height. This is the height of the triangle. Now, you have to remember that the height of the triangle is the same as the height of the rectangle. So as soon as we find the height of the triangle, we'll also have the height of the rectangle. Now, we're also missing the base of the triangle. That's from here to here, so we're missing B. We're going to find those two things first, and in order to find the height and the base of the triangle, we're going to use our old friend, the trig ratio. So let's write out so Katoa. And of course, as always, we have to label in reference to this angle to find H and B. Now, 12 inches is the hypotenuse. H is the opposite side, and B is the adjacent side. Now, step one, we're going to find the height, H. And in order to find H, we have to use the opposite side and the side that we know the value of. So if I use opposite and hypotenuse, that's going to be the sine ratio. So I'm going to write the sine of 40 degrees equals opposite over hypotenuse. The sine of 40 degrees equals H over 12. And we're going to put sine of 40 degrees over 1. We're going to cross multiply. 1 times H is H. When we cross multiply this way, we're going to get 12 times the sine of 40 degrees. And let's type this into the calculator. So 12 times the sine of 40, and we can round that off to 7.7. So 7.7, and that'll be inches. That means that I can put 7.7 inches here, and I can also put 7.7 inches here. Step 2 is going to be to find the base. That's this variable here. And in order to find the base, we have a few options. I'm looking for the adjacent side. I can certainly do cosine, adjacent to hypotenuse. I can also do tangent, opposite and adjacent. And now, since I have two sides of the right triangle, I can also use the Pythagorean theorem. We're just going to do cosine here. I mentioned that one first. So cosine of 40 degrees equals adjacent over hypotenuse. So the cosine of 40 degrees equals B over 12. We put the cosine of 40 degrees over 1. We cross multiply. 1 times B is B. When we cross multiply this way, we get 12 times the cosine of 40 degrees. And let's type that into the calculator. So 12 cosine 40 degrees. And we're going to round that off to 9.2 because this is a 9 here. That'll make the 1 round up, and that'll be 9.2 inches. And we're going to put that down here. So 9.2 inches. Step 3 is going to be to find the areas. So first up, let's find the area of the rectangle. And the formula is base times height. Now, the base of the rectangle, we said, was 16. The height of the rectangle is 7.7, so let's plug that in. 16 times 7.7, and we get 123.2. So 123.2, and that would be square inches. Next up, we're going to find the area of the triangle. So 1/2 base times height, 1/2. Now, the base of the triangle, we just found that, 9.2. The height of the triangle, 7.7. 0.7. Remember, we said over here the height of the triangle is the same as the height of the rectangle. So let's plug that in. Now, 1/2, remember, that's equal to, if you just type 1/2 into the calculator, it's just 0.5. So we're going to use that 0.5. 0.5 times 9.2 times 7.7. And we get 35.4, we'll round to. So 35.4, and that's also inches squared. So our total area, I'm going to call it A total, is going to be this area, 123.2, plus this area, 35.4. And let's type that in and see what we get. Now, we learned in one of the previous videos that you don't have to type in the 35.4 again, but since I do have 35.42, I'm going to actually have to type that in. So 123.2 plus 35.4, and we'll get 158.6, so 158.6, and that'll be inches squared. All right, this concludes the similarity and right triangle trigonometry test review. Good luck to all of you.